Well, welcome to my talk, everybody. It's code execution with JDK scripting tools and the Nationwide JavaScript engine, and I'm Brett. Hi. So just before I get started, just a disclaimer, this research was done on my own personal time, and it's in no way affiliated with my employer, and all views and opinions are my own. All right, so a little bit about me. As I said, I'm Brett. Born and raised in Ohio. Been in InfoSec for about 7 years now. Worked for multiple companies across different industries. Started out on defense and then moved over to offense. I've been on offense for a while now. Did some undergrad work at the University of Akron, some postgrad work with SANS. I have some certs there from SANS and offensive security as well. And in my free time, enjoy doing security research, which is kind of how this came about. Also like doing programming, play lots of different sports and video games. Any Call of Duty fans, it comes out next Friday, by the way. So just a little outline kind of how this talk's going to go. I'm going to give a high-level overview of the Java Development Kit just to give you a background of what it is. Then I'm going to talk about some JDK scripting tools that I found. Then I'm going to give you an overview on the Nationwide JavaScript engine. Then we're going to use those three things, and we're going to talk about it from an offensive perspective and actually apply that practically. We're going to switch gears over to defense and talk about some detective and preventive controls that you can implement for the usage of these tools. And then we're going to go over a defensive control evasion concept for those controls, and then we're going to have a demo at the end. So why am I doing this talk? I wanted to give back to the security community. The community's given me a lot throughout my career, so any time I have the opportunity to give back, I like to do that. I love security research. I'm just very passionate about it. And also, you know, offense is getting harder, which is a good thing, right? So the hospital that you and your family and friends go to, you probably want to keep getting more secure. The bank where you store your money, you probably want that to keep getting more secure, right? So it's a good thing that it's getting harder. Having said that, from an offensive perspective, we need to constantly innovate and push the envelope, right? We constantly do that, and that's kind of why I'm doing this talk. As far as who this talk is for, so how many of you raise your hand if you're on the offense? So you do pen testing, red teaming, whatever. Okay. How about defense? So whether it's SOC, forensics, security engineering. Okay. So a little bit of everything for everybody, right? So those of you on the defense, you're going to get some IOCs for a new code execution technique. That's what you're going to get out of this. Offense, you're going to get a new code execution technique. You're also going to get an evasion concept for those IOCs that I'm going to talk about as well. So there's going to be, naturally, yeah, I mean, I'm on the offense, so, you know, that's the way it is. As far as how I got the idea for this research, I always find this fascinating when, Casey Smith or Matt Graber, they post their research, like, how did you get this idea? So I started thinking about, from a post-exploitation standpoint, the different programming language trends, right? I was initially kind of thinking from a Windows perspective. So PowerShell, obviously, everybody knows about PowerShell. Like, it was very popular. Well, Microsoft's made a lot of improvements, right? A lot of third-party security products have made a lot of improvements, which has caused us as the offense to migrate to C#. So that's why you see a lot of these projects from the guys like SpectreOps, like Sharpsploit, and GhostPack, right? Because it's time to move to C# now. So I started thinking about, well, what happens when, what happened with PowerShell happens to C#, right? What happens when there's like sufficient, defensive telemetry around C#? And then I started and made me ask the question, well, what about a programming language that there's a high probability it's going to be installed on multiple platforms? So I started to think about this, and that's when I came up with, what about Java? Now, some people are probably like, oh my gosh, Java is supposed to be dead by now, but frankly, it's not. I mean, raise your hand if you don't have Java installed in your organization. 0 hand. Really? Okay, well, one person. So yeah, so it's installed on servers, it's installed on endpoints, right? It's everywhere. So why not Java? And that's kind of how I started going down the road of looking at the different components installed with Java. So Java Development Kit, what is it? Again, just high-level overview. It's a full-featured software dev kit. It includes a Java runtime environment in it. If I had to compare it with something with a .NET framework, it'd be like the .NET Framework SDK for developing .NET apps. What's the difference between the JDK and JRE? I mean, Really, the JDK, it's used if you need to develop, applications, or if you have a Java web application, you would need the JDK installed on there. Java runtime environment is just for your normal user. It's just got the Java virtual machine on there where Java programs can run, including like Java applets. Bob from accounting doesn't need the JDK. He just needs the Java runtime environment. Although Java 11 that was just released last week, they're no longer offering a standalone Java runtime environment for desktops. They're only giving a JDK and a server JRE. So starting with Java 11, which was just released last week, that's the direction that Oracle's going. From a version history standpoint, JDK beta came out in like 95 all the way to Java 11 that just came out last week. We're going to focus on starting with Java 6 because that's when one of the tools that I found was released. But we'll really get heavy into like Java, starting with Java 8, as you'll see. But that's kind of the way it is from a history standpoint. Oracle's plan now with Java 11 is they're actually going to do releases every 6 months going forward. So they're going to do a more rapid release schedule compared to what you've seen before as far as the gaps between releases. So that's just a high level, the Java Development Kit, just to give you kind of an overview. Now I want to talk about some of the tools that I found that are installed with it. So first off, how did I find these tools? I looked for signed binaries installed with Java, the JRE and the JDK, that contained at least one. I had 3 criteria I was looking for. I wanted something that could execute system commands, something that I could use as a file downloader, and something that could execute interpreted code locally or remotely. So I was looking for binaries that were installed that could do at least one of those 3 things. I didn't have any crazy like discovery methodology. I literally just went through one by one and looked at them, looked them up on Google, looked them up on Oracle documentation. I didn't have a crazy script running to like find these things. That's all I did to find these. So the first tool I found when I was going through was JRunScript is the name of it. JRunScript, it's just a command line scripting shell installed with Java, and it can be used to execute code that it's code interpreted by supported JavaScript engines. It was installed starting with Java 6, specifically starting with JDK 6 and higher it was installed, and starting with Java 9 it actually just comes with the Java runtime environment, so it's not like you have to have the Java Development Kit. Even with just the JRE 9 it's going to be installed. And this snippet down here, this is from Oracle's documentation. It's been listed as experimental since Java 6, but it's still sticking around, so I mean, it's fine with me. But when I was looking through, something caught my eye as far as the switches that were available with it, and that's this -E switch. So it says evaluate given script. So I was wondering, well, does that mean I can pass code in line and it'll execute it? Are there some sort of like global functions that I can pass to it? And that was exactly the case. So when I was looking up the different global functions, again, what I said was I was looking for something that could execute interpreted code locally or remotely, could be used as a file downloader, or could be used to execute system commands. So these 4 global functions that you can pass to JRunScript do exactly that. First one, cat, says shows the content of a file, URL, or input stream. URL being the keyword, so I'm like, oh yeah, there's a file downloader, awesome. And then the copy function said copy a file, URL, or stream to another file or stream. Add URL, so I was like, yes, another file downloader, awesome. And then the exec function was pretty straightforward. You can start a child process, whatever you want to put in there. But then my favorite one was the load function. So with the load function, it can load and evaluate JavaScript remotely. So what that means is it can remotely fetch and execute a JavaScript file without dropping it to disk, whether it's from a web server or from like a file share with a UNC path. And you're going to see examples of this too in my demo that I'm going to be covering. The second tool that I found was JJS. So JJS stands for Java JavaScript, very classic. So again, it's installed with Java. It can be used to execute code interpreted by the Nashorn JavaScript engine, which we'll cover in a second. It was installed starting with Java 8. It includes the JDK and the JRE, so even with just the JRE, it's installed. Paul Ritchie, who is at Corner Pirate on Twitter, has a great blog post on JJS. I highly recommend you take a look at it. And again, this is just a snippet from Oracle's documentation. You can see its description is, runs the Nashorn command line scripting shell. When I was looking this tool up and doing research on it, I didn't really find anything useful, too useful like I did with JRunScript. The only thing that I found useful was the fact that you could execute local scripts with it. So that's, I mean, it was one of my criteria, but it wasn't as juicy as JRunScript was. As far as where these files are located, Windows on a default install, it's within your program files directory, then Java, and then whatever the JDK or JRE version is. On Linux and macOS, default installs in user bin. Just a note for Windows, if you don't know what version JDK or JRE is installed and you want to call JRunScript, this bolded text you can put before it and it'll just automatically choose the right one. So I've gone over the Java Development Kit, went over these scripting tools. Now I'm going to talk about the Nashorn JavaScript engine. So what is the Nashorn JavaScript engine? It's a code engine that can execute code, right? I mean, it can interpret and execute code, but specifically, it can execute JavaScript and also Java. That's the big thing, is the fact that it can execute Java. It started out with the Mozilla Rhino JavaScript engine back in 1998, and then Nashorn came out in 2014, and then Oracle is actually moving to GraalVM in a future Java release. So starting with Java 11 that just came out last week, Nashorn was actually marked as deprecated, so it's going to be removed in the future. I don't know when that is, which Java release, but I mean the fact of the matter is Nashorn is going to be around a while still. As far as the scripting syntax, I could go through like how to initialize variables and iterate through for loops and stuff like that, but the link I have there, I mean, just check that out. It's got a bunch of good stuff on there. The example I have here is just an addition program. It's got an array of numbers. It iterates through each one of those with a for loop, and then it prints the sum. So it's like a very basic JavaScript code. But what I was mentioning with Java, so the big piece with the Nashorn JavaScript engine is that you can execute Java code. So this is a basic example of doing that. So what we're doing in this example is we're initializing a process name called calc.exe, and then we are accessing the java.lang.runtime object and assigning that to the runtime Java class variable. And then with that, we can execute the methods that are available in that object. So this is a very simple example of using Nashorn JavaScript to execute Java code. There's a great example at the link up top that I have there. But really, I mean, with this, the sky's the limit. So like if you have like a custom rat and you want to write a Nashorn JavaScript agent for it, you can do that, right? And then going the other way, you can also invoke the Nashorn JavaScript engine from Java. And you're probably wondering, well, why would I want to do that? I have an example of why you want to do that a little bit later. So in this example, you can see this is Java code, and it is using the script engine manager object. And then we have the script engine object that is getting the Nashorn JavaScript engine. And then from there, we can call nashorn.eval, and then whatever the function name is. So the functions that you saw I had listed, so you can access the Nashorn JavaScript functions from Java. And again, you're going to see why this is going to be useful a little bit later when we talk about evasion. So you've seen the Java Development Kit at a high level. You've seen the JDK scripting tools. You've seen the Nashorn JavaScript engine. Now let's actually apply it from an offensive standpoint. Let's actually use these things, right? So the first one, downloading files. The cat and the copy function. Those are the functions you can use as a file downloader. And I have a link to my gist where I have these examples that are listed here. You can download from a web server. You can download from a file share via UNC path, either one. Something for you defenders, you're going to see when I get to the defensive section and also in the demos. Any of these functions that remotely try to touch something, as a file downloader or even the load function, it uses a specific user agent string that you can actually key off of. And in the evasion section, we'll show how to try to get around that. So the next one, execute system commands. So with the exec function, it's very straightforward. You just pass it the command you want to run. So this first one's for Windows, obviously. We're calling cmd.exe and the dir command. And then for Linux and macOS, we're doing bin bash with ls. So it's a very straightforward one. You can also load and run local scripts. Again, with JJS, this is the only useful thing I found. With JJS, you can also pass like -f in the path to the script as well. So again, that's a really straightforward one, and you'll see this again in the demo as well. My favorite function, as I said, was the load function. So With that, you can see my first example. I'm passing it a web server to remotely fetch and run the Nashorn JavaScript file. And then the second example there, you can see giving a UNC path where it'll pull the file from a file share with the UNC path. So this is very powerful and probably my favorite one because nothing has to drop to disk, right? From an offensive standpoint, we don't have to drop anything to disk if we don't have to. And then you can also do a one-liner reverse shell. This one-liner reverse shell, this is from Chris Frohoff, who I have his gist linked here. I just simply copied his code, and then I have like another example that I made with Bash. But it's very simple. You can see we're calling JRunScript, and we're actually passing Nashorn JavaScript code in line. So we initialize this host variable, which is our attack IP. We have a port that we're sending the shell to, and then we're having cmd.exe, which is the process we're going to be sending across the wire. And in there you can see we're accessing the java.net.socket object, java.lang.process builder, right? So again, it's very powerful to be able to do like the one-liner reverse shell. And you're going to see an example of this as well. Base64 encoded one-liner, this is pretty cool. Again, the one-liner itself is from Chris Frohoff. I just copied it. So what you can do is you can create a Nashorn JavaScript file. You can get the base64 encoded representation of it, and then just paste it into the one-liner, and it will run that. And you're going to see that on a Mac example during the demos as well. So you can see kind of how useful this can be from an offensive standpoint. But what are the advantages and disadvantages? You know, there's positives and negatives. So advantages, there's no native logging for the usage of these tools or the Nashorn JavaScript engine. And what I mean by native, how PowerShell version 5 has script block logging. There's nothing like that with these. Another thing is it can assist in the evasion of host-based security controls that look at may rely on or factor in parent process relationships. You know, could throw it off a little bit. No need to drop anything to disk because these tools come with JRE or the JDK. They're signed binaries by Oracle. They're not some unsigned, unsafe executables on the system. And it's supported on multiple platforms, which is nice. So if we ran on Windows, Linux, and Mac OS, they're installed on all those. Disadvantages is that it does require the JRE or the JDK to be installed on the target system. But again, high probability that one of those is installed in an enterprise. So went over some practicality from an offensive standpoint. Now let's switch gears to the defensive side. Switch into the blue side here. So we're going to talk about some detective and preventive controls that you can do, you can implement. Going to talk about full command line logging, user agent string monitoring, and process monitoring from a detection standpoint. Then from a preventative standpoint, we're going to talk about application whitelisting and then simply just uninstalling them. So the first one, full command line logging. This is just a default install of Sysmon. I'm by no means a Sysmon expert, just had a default install. So with Sysmon, you can do full command line logging. So you can see here, there's a process create with JRunScript. You can see I'm calling the load function to remotely load a reverse shell that I'm hosting on my web server. Full command line logging is one thing, but you need to get those logs sent to your SIEM and alerts built off of those logs, because if you're just logging with nothing else, it's pointless, right? So that's something that you need to take a look at. Second one from a detection standpoint is user agent string monitoring. As I mentioned, the cat function and the copy function, and also the load function, anything that's remotely trying to grab something, those functions use a specific user agent string, and it's Java / whatever the Java version is. So what you can do is you can implement rules in your proxy that will look for this user agent string, because it does kind of stick out. And then another detective control is process monitoring. So start monitoring for processes running or jrunscript.exe or jjs.exe. Just keep in mind that, these files could be renamed and executed, but if an attacker has the ability to rename something in program files, you have bigger problems. Yes, but below you just see I'm just filtering on jrunscript.exe, and you can see that I was running the load command. On the prevention side, application whitelisting has got a lot of attention lately. So you should implement a robust application whitelisting policy, which includes blocking JRunScript and JJS. Below here, these are the default executable rules with AppLocker. You're going to need to do more than just the default rules. If you take a look at the third one down, it says allow all users to run executables in the program files folder. If you remember, I was talking about the default install for Windows. Those tools get installed in program files, right? So you need to tweak it beyond the default rules in order to prevent those from executing. And then just simply like uninstall the JDK or uninstall the tools. There's no reason, you know, like Dwight says, there's no reason for Bob to have these in accounting. So if you have the ability to survey the software inventory in your enterprise, take a look at where the JDK is installed and uninstall appropriately. If you can't uninstall it, at least remove those tools. So the question was, on the initial install, if you were to delete these tools, if that would break anything, any type of dependency. I'm not quite sure. I haven't heard of anybody that actually uses these tools, like as far as a developer. Or just come back anyway? Yeah, okay. Once the updates, yeah, once the updates happen, so. Yeah, the research I was doing, I didn't see there was really any dependencies at all as far as something that would break in Java. I mean, I didn't see anything. All right, so now, I talked about kind of from a defensive standpoint, some detective and preventive controls you can do for the use of those tools. So what I wanted to do is I wanted to challenge myself. So I'm on the offense. So you know my job is to bypass and evade controls. So I tried to think of a way that I could bypass or evade the controls that I actually recommended for those IOCs. And that's when I came up with the concept of BYOJ. So BYOJ is bring your own JRun script. So it's just bringing your own command line tool that has the functionality of JRun script. A couple of scenarios where you could use this. One is where like at least Java 8 is installed, but JRun script is not, whether you know JRun script was removed or the JDK is not installed. The other scenario is if JRun script is on the machine, but you're worried about some security controls that could detect it. So for example, like the easily detectable user agent string, right? So that's the other scenario where this may come in handy. Advantages and disadvantages of BYOJ. You can customize a user agent string to make it blend in with the environment. You can, with this, you can interact with the Nateshorn JavaScript engine when JRun script isn't there. You can also evade the process monitoring and full command line logging rules that I talked about that would look for jrunscript.exe running or being created because you're not going to be using JRun script. And also, again, it runs on multiple platforms, so it's just going to be running in the Java virtual machine, so to run on Windows, Mac, Linux. Disadvantages is it requires dropping a compiled file to disk. So like I said, from an offensive standpoint, we don't want to drop something to disk. We don't have to. But in this case, since you're bringing your own tool, you would be dropping it to disk. So how do you create your own JRun script? I'll go through each one of these in detail. But from a high level, basically you're going to determine the functions you want to implement. You're going to get the source code of them, of those functions, convert that source code to Java, add some command line switches, and then compile it into a class file. So as far as determining the functions to implement, for mine, again, I wanted the file download functionality. I wanted to be able to execute interpreted code locally or remotely, and I want to be able to execute system commands. So the functions that I chose to implement were cat, copy, exec, and load. There's others that you can implement, but those are the ones that are important to me. As far as getting the source code for those functions, on your dev box, you can drop into the JRun script shell, and then you can type a function, and it will return the code for you. Now there's a difference between non-native methods and native methods. So a non-native method like exec, it's just going to spit everything out for you. A native method, load, is actually easier to do in Java, you'll see. So there's non-native and native methods. So the native method doesn't disclose all the code, it just says, oh, it's native code. So now you have the source code for the functions. Now you need to convert those to Java, which as you can see, like here, like it literally has the Java code in here, so it's not a big deal. So for the exec function, that's a non-native method. So it's pretty much a one-for-one conversion from what you just saw. So we convert it, and there's your function there for exec. For a native function like load, where it did not show you all the code, it's very simple. You can literally just call the eval method that's available in that script engine object that you saw early in the talk, and just nashorn.eval and whatever the function name is. That's all there is to it. So it's a lot easier to utilize the Nashorn JavaScript functions in there that are native. So now that you've got all your functions converted, you can implement some logic in your main function. You can put some switches in there to make it user-friendly, and then compile it with Java-C on your dev box. Just make sure you have at least Java 8, since it's going to be using the Nashorn JavaScript engine objects. Once you've compiled it, you can transfer it to the desired machine, and you can invoke it like below. The link there is my gist, and I have a BYOJ POC that has all these implemented, so feel free to grab it, play with it. So that's one that's kind of an example of proof of concept you can play with. Now, what does this look like? I talked about the point of this was to kind of evade some of the detective and preventive controls that I was talking about. So what does this look like? So as far as the user agent string detection, so here's using BYOJ to do download with cat. You can see the user agent string below looks pretty normal, right? A lot better than the Java / whatever. So it's going to blend in with the environment that you're in. And that applies for like the cat function, the copy function I implemented. One thing you'll see in the examples is that for that native method load, how it remotely fetches the Nashorn JavaScript code, even though you set the user agent string for that, it still appends Java / whatever at the end of it. So it's kind of a bummer, but it still like appends that at the end. Process monitoring, like what I recommended was look for jrunscript.exe running. jrunscript.exe is not running in this case. It's java.exe that's running because Java is calling the BYOJ file. So that'll evade that rule. Full command line detection, I recommended that you create rules for like process creates with jrunscript.exe and get those sent to your sim and alerts built off of them. In this case, jrunscript.exe is not, the process is not being created. It's java.exe that's being created. So again, that will kind of get around that as well. And with application whitelisting, it's still applicable. As you saw, the default installs are within program files. So if you have the default app locker executable rules, it'll still get around that. So you just mean, obviously you're not going to block Java from running, but this is just kind of showing how you can, from an offensive perspective, kind of get around that a little bit. So let's see it in action, right? Let's see the demo. So you saw everything from an offensive perspective, a defensive perspective. Now we're actually going to see some demos. So all right, so we got a couple Windows demos here. Now this first one, what you're going to see, the load function that I talked about, where you can remotely fetch a Nashorn JavaScript file and execute it. You're going to see us doing that with jrunscript, and then you're going to see that with BYOJ, so you're going to see the difference. So here, I have my listener running, and then I'm tailing the Apache log, so you'll be able to see what the user agent string looks like. Go over here to our Windows machine, hpotter. We're going to get a lot of shells on Harry here. So, pause this. So you can see here, that string that I was talking about that you can add before jrunscript, it'll just do, because it'll choose the correct Java version. I added that, and I'm calling jrunscript with the load function, and then what I'm going to be doing is remotely fetching revcmd.js. You can probably guess what that does. Fetching that, and then running it. So we're going to run that. And we go back to our attack box. You can see the user agent string right there, Java with the Java version. So on the victim box, we had Java 10. You can see our shell came in here. You can interact with the shell, see who we are, host name, right? So now we're going to do the same thing, but we're going to use BYOJ, and you're going to see what that looks like. Still got our listener up. And again, you're going to see here how I talked about, even though I modify the user agent string, it still appends the that Java/Java version after it. So here we go, Java, I'm just going to call BYOJ. Again, we're going to be loading the revcmd.js script. Run that. Shell came in. So look at the user agent string, right? So at the end, you can see it has Java / the version. Even though you set the custom user agent string for that native function, it still appends that at the end. So defenders, if you had like an exact match on the user agent string with the Java / Java version, that would get around it. So make sure you do something like a contains, like if it contains Java / with the Java version. So then we go back here, and you're going to be able to see that we had the shell that came in. And again, we can interact with that shell. You could, when you're doing testing, you can catch this with Netcat, but I just catch it with Metasploit because it can handle multiples. All right. And the second example on Windows, what we're going to do is we're going to use the copy function with JRunScript to download a Nashorn JavaScript file, and then we're going to execute with JJS. After that, we're going to do the same thing, but we're going to use the BYOJ. See what that looks like. So again, we have our listener up. We have the Apache log being tailed. All right, so we're going to go over here to our victim box, over to Harry's box again. Copy that. Pause it here. All right, so you're going to see here, right? So we're calling JRunScript, calling the copy function. We're copying revcmd.js over into ctemp. So we're going to run that. Then we're going to prove that the file is actually there. Is. All right, so there's the file, right? So now what we're going to do is we're going to use JJS to execute it. But first, let's take a look at the user agent string. So again, that's using JRunScript with the copy function. There's a user agent string that sticks out. So then we're going to execute that file to get our shell. Got lots of shells on Harry. All right, go back there to attack box, and there it is, right? So we can interact with it. So now that next example, it's going to be the same thing, but we're going to be using BYOJ for the download. With this, it doesn't append the easily detectable user agent string afterwards, so it's really going to blend in. So now we're going to do the same thing, copy the file. Same syntax. Paste that in there. All right, so we got it downloaded. So we should have a revcmd byoj.js in ctemp. So there it is, right? So then we're going to switch back over to the attack box, and we're going to see the user agent string. That looks a lot better, huh? Definitely blends in better. Then we're going to execute with JJS again to get our shell. Copy that. Get the picture. There we go. Oh, there's our shell. So that's the Windows examples. From an event log standpoint, I want to show you what that looks like in sysmon from that activity we did. So you can see here, there's the process create. That goes away. There's the process create for JRunScript running. You can see JRunScript executable, and you can see I was calling the copy function to download. We go up here, you're going to see jjs.exe running. Again, you need to get these logs sent over to your SIM. But you can see those right there, plain as day. And then just to show you, we're also going to search for the process create that was used for the calling BYOJ as well. Just search for that. You can see there. Next one. Yep, there it is. So there's Java, BYOJ with the load function. So you can see that there as well. So those are the Windows examples. I'm going to show you a couple things on Mac. So with Mac, we're going to show the base64 reverse shell. So what we have, we have a JavaScript file, so revbash.js. Pause here. So you're going to see here the host IP is right there, the port, and then that's the process we're sending across the wire. So bin bash. We also have an argument there, -i, so we're going to send an interactive bash shell across the wire. It's not a TTY, but it's an interactive bash shell. So that's the code that we have right there. So then what we're going to do is we're literally just going to take this code and we're going to get the base64 encoded representation of it. So pipe that to base64. So we have that. We're going to take that and we're going to paste it into our one-liner. And then we're going to run that. Again, this is why it's nice that multiple platforms. Run that. And there's our listener. Our shell. Interact with that. See we're Hawk there. That's all there is to it. Last example on Mac is just going to show just the cat function, just to download a file. We're going to show with JRunScript, and we're going to show with BYOJ. This is the last function. So you're going to see we have the Apache log up there. You can see we have no file that's called DerbyCon. We're going to use JRunScript -e with the cat, and then we have the path to the web server. Download that as derbycon.txt. You can see that's there now. Cat that out. Hi, DerbyCon. So you see there's the Java version, so Java 1.8. Now we're going to do the same thing with BYOJ, and you're going to see that the user agent string is going to look a little bit better, and it's going to blend in. Copy that. Paste. And you can see there's the file again. There it is. Hi, DerbyCon. And there we go. There's a user agent string that you see blends in a little bit better, right? All right. So with that, that's all I have. My Twitter is right here. I'll be posting the slides actually next week. I also have a blog where I actually have a couple posts on this very topic. Also want to thank DerbyCon staff. I really appreciate them giving me the chance to talk this year. With that, I will take any questions. So you said, would it be possible to include a renamed copy of JRunScript instead of your own? So actually, that's a very good question. So whenever, where JRunScript is in the file directory, it actually depends on, there's a DLL that is one directory back it depends on, and there's also a jar file that it depends on. So it wouldn't be as easy as just copying the exe. So you'd actually need to copy the directory structure it needs with like there's a jar file, it's maybe tools.jar or something, and then there's also like a DLL file. Yeah. Yeah, so the question, he said for my evasion, he said I would just rename it to your JRE update. Yeah, like in my example, like I just called it BYOJ obviously for the example, but yeah, I would definitely name it to blend in. Mm. Well, yeah, and the thing with that, so you would need privileges to rename it though in program files. That's the thing. So you need admin. Mm-hmm. Mm-hmm. Oh yeah. No, yeah. Again, this is just for the example. I'm just naming stuff test, but yeah, obviously. Right. Yeah, you can do multiple things to blend in, but yeah, excellent idea. The question was, in order to do this, do you need to be a local admin or just a regular user? Just a regular user. No admin pros. Any other questions? All right. So the question was, what is my preference for the remake of Point Break compared to the original Point Break? This is an inside joke, but yeah, the new Point Break is much better than the original. So Getting a bunch of boos now. I'll try to watch the original. I couldn't get past 15 minutes.
So, can you look at the live feed of Jake?
Yeah. Yeah. Jake, you're watching. Shaddy wanted me to say something to you, but I'm not going to say it. Any other questions? Yeah.
Have you experimented with Rollium?
No, I've not, but I just read up on it briefly. Apparently, they're actually going to be, they have backwards compatibility with Nashorn and JavaScript, so that'll be nice. But yeah, that's probably going to be another topic I'm going to research since they're going to end up moving to it. So yeah, interested to see what that's going to have in it. Yep. Any other questions? All right. Thank you, everybody.